Hello, this is the second video I'm making to explain the engine sounds I made and implemented in Unreal Engine using Metasounds. So on the previous video we saw how I divided the range of RPMs, possible RPMs, and the equivalent pitch, and I made the 6 loops to cover all the range. So this is the vehicle engine we were watching. Here are the values that are set for the crossfades for each segment. And well, here in this section, these are the 6 players that play each loop. Each of them have an input of the onload and offload sound, because for each pitch, for each RPM, you can have onload or offload loop sound. So in here, this is how I handle it. Here, the 6 wave players, the 6 sounds are played, and depending on the RPM, this area here will just will lower the level down of the ones that should not be heard, and just let you hear the correct one, or maybe 2 if the RPM is on that crossfade area. So first, here I will show one of these. They're all the same. All right, so well, here you input this is the current RPM that the car has at the moment. It's updated all the time, and for it, all these have the same RPM input, but each of them you need to enter the minimum and maximum RPM that each kind of loop should play, and how much should be pitched down or up. So as I show here, the first loop, it's pitched down 3 and pitched up 3 semitones, and the others are pitched down 4 and pitched up 3. That's what it shows here, -3 and 4 the rest, and max pitch 3. And well, also the RPM that they should be playing, the RPM that matters for each loop. So for the first one, the minimum RPM is the start, and the end is the crossfade one end here. And for the others, for the other 5 loops, the lower RPM is the crossfade start, and the higher is the crossfade end, the next crossfade. This is the first one, second, third, like that. So, for instance, the second loop will start playing at the first crossfade start and finish at the second crossfade end, and so on. And well, it also, of course, has an input of the throttle input that will determine if the onload or offload loop will be heard. So to show one of these now. Okay. So here it has a map range, right? So it shows you input the current RPM, the minimum and maximum that plays, and the min pitch and max pitch shift, right? The -3 or -4, and 3 or 4, and 3 is always the maximum. So that will determine how much should be pitch shifted each asset. The same for the onload asset and the offload asset. Right? I hope that's clear. So for the minimum RPM, it will be pitched down 3 or 4, depending on which loop is. And for the maximum will be pitched up. The output value will be this one, right? 3. That goes here. So here, this, you see, would play both on-load and off-load, but this area here determines the level, right, of the on-load or off-load asset. So depending on the throttle input, if the throttle input is 0, you will hear the off-load asset. And if it's 1, this is actually always or 0 or 1. There are no intermediate values input here. So, yeah. And, well, of course, what I did here is like a... So it doesn't change like right away. It will change in a period of 0.7 seconds from on-load to off-load. So it sounds more natural, a little better, right? I don't know. I've been changing this amount of time a lot, but okay. So this is more used, I will use it more for another part of this system, but basically is this. I have here, so we can check it better, what it does. If the input is 0, the output of the first output is 1, and if the input is 1, the output the second output is 1. If the input is 0, the first output is 1 and the second is 0, and if the input is 1, the opposite. So this will cause that you will hear the correct asset. I don't know why this keeps, I don't know, I touched something here. Okay. All right, this will determine here which of the two assets, right? So if the input is 0, this output will be 1. So you will hear this second one, that is the offload asset. And, well, the opposite if this is 1. This is just a level, just to make it a little bit lower, but just that. Okay, so this will handle the pitch shift of each loop, and it will determine what we saw here, if you will hear the on-load or the offload asset. And, well, what I was saying before, if you only have that, right, you will be hearing the 6 loops at the same time. So what we have here is a crossfader that receives all these crossfade starts and ends and outputs the correct level depending on the RPM, right? So this will show if it's a lower RPM, the input will be 1 here, and on the rest will be 0, and so on. So you hear the correct one. I would like to, my idea is to think a way of optimizing this now in the future, so you don't have all the 6 players playing. But right now, this is how I made it. This is the crossfader, right? You input these map ranges and uses, this is hard to explain, but yeah, you input, it uses the same I showed before. That is this that I'm testing it here. What I can show, you need to try it to make it. I can show it more detail, but these are all the same. The crossfade start and end of each. And this, and you get the correct value. It's this, what the good thing of this also is that it makes, for instance, if the input is in the middle, right? If you are in the middle of a crossfade between 2 segments, the output of each one is 0.7, so the crossfade is like this, equal power. It's not a linear crossfade. That's how you will hear the correct loop. And well, as I showed before, this will show, I mean, this one will let you hear only the correct loop, the correct frequency depending on the current RPM. And this will handle if you hear the onload or offload asset. And well, here is just a little bit of a high pass. And here what I do with the speed is to manage the gain of this high shelf filter. So from 0 to 180, the speed, the gain of a high shelf will go from -18 to 0. So it will reduce the high frequencies if the speed is low. And the same here with this low shelf. Like, if the speed is lower, you will have less of the lower and higher frequencies. Once the speed increases, it will increase the gain of both. And finally, let me see. Okay, I think this is enough for this video. The next time we can see the idle and how I got the values from the movement component. Thank you. See you soon.